then we will change. Okay, so this morning we will see that how to use the coupling toolbox that we have developed actually to help you run couple simulation, because as you saw yesterday, it's a bit painful to fill all the files that are necessary to perform a couple simulation. So basically, what this toolbox is doing is it is automatically filling all what you have seen yesterday that were in brackets in the files. So all the time steps settings, grid settings that were in all the different names from the model and also from the couplers of the NAM couple. And so this toolbox is automatically filling all this. So I will first a bit introduce what it does. Then I will show you how to use it on the Angular simulation that we did yesterday. So basically, what this coupling toolbox does, so what it does not do is getting the source code. So this you have to do by your own. And also, you have to compile your code in advance. What the toolbox does is compiling CROCO, because as CROCO compilation depends on the size of the grid and stuff like that, you can fill the CPP depth and the param.h files and compile CROCO if you activate it in the my_name_is file. I will show you that. Then you have to pre-process, do the pre-processing for your different models. And then what the coupling toolbox does is defining all the name lists and moving the input files from where you put them during your pre-processing towards a run directory. And then it's running the simulation. Eventually, it's restarting the simulation to the next month. For example, if you are running multiple months and you want to have chain jobs for this multi-month simulation. And then it's putting the output in different directories. So you will have a directory for indeed output of the model, but also directory for restarts that are stored and things like that. So basically, you remember this little schematic of all the steps that we are supposed to do, and the toolbox is doing much of it. So basically, it's preparing the name list, as I said, it's preparing Oasis input files, and it's getting and moving the input and the output. So here is a little schematic on the right on how this toolbox is built. So it's not very easy. So there are multiple scripts, as you can see. So it's a representation of the workflow and the philosophy of the coupling toolbox. And I will show you a bit more, explain to you a bit more how it works. But basically, normally on your side, the only thing that you have to modify are the my files. So the my of my path, that is setting the environment on the path, the my name list, that is setting different things for the experiment, like which model are you using, what are the time stepping for the different model, what are the grid size, what are the input files, etc. And then the my job file that is setting the job settings. So typically the date, if you want to perform a one-year simulation at once or by month by month. If you have also the HPC settings, so how many processors you want to allocate for each model and stuff like that. So in the my job. So basically, these are the only scripts that you have to modify normally. And all the other ones that are written on the right will be are the functions that are used by these three different scripts. And there is one of the scripts that you will see in your main directory is the submit job. And the submit job is actually, you don't have to modify it. It's just the way you launch the simulation. So the my path, my name is my job, you have to do modification in that. But the submit job, you just launch /submit job. And it's /submit job for each machine. And this submit job will aggregate all the settings that you have put in my path, my name is on my job, and prepare the job and launch the job with a good launcher that you have depending on your machine. So for example, in Electrao, it will launch a sbatch command to launch the job at a certain point. In this toolbox, so you can see the scripts for this toolbox are stored generally in CROCO source. So when you download CROCO code, you have a directory that is named scripts, and in this directory there are different scripts that are prepared for different use, and there is a script coupling, and this script coupling is where you will find this different scripts, but you don't have to change anything in CROCO sources. When you use create-config.bash, it's deploying all these toolbox for you if you choose all prod.cpl, what we did yesterday actually. And when you do that, if you remember, you will have a new configuration that you have decided, and inside the directory of this configuration, you have the my path, my name list, my job, submit job, and here script toolbox, which is the toolbox containing all the script that you will require to use. So the other things that this toolbox is doing, it has different scripts, as you can see. So here I have listed what's in the script toolbox. If you do ls in the script toolbox, you will see the same. I will log in on the machine, and you can do the same. So I will log as yesterday as student 98 for me. You can log on your own user. And so if I go into my config directory, Benguela CPL configuration, and I check what's there, so I have indeed the typical architecture. And if I look at script toolbox, here I have indeed these different scripts that are within the toolbox that you should not have to modify, but it's just for you. I just wanted to explain to you how it works. So basically, what this toolbox does, it has different command definition, tools for computing dates, because you have sometimes leap years and the months are not all the same duration and stuff like that. So everything of that is in CalTools. Then you have base for building the job that will be launched. You have things for chaining jobs together. And here you can see that for each type of model, you have different scripts. So we have the get file, so it gets the input file for the models, the get restart, that get also the restart files. You have something that is filling the name list of each model. So you can see that you have that for each kind of model. So add get file, add get restart, add get num, add put files to put the files in the output in a different directory. And you have that for the atmospheric model, for the ocean model, for the wave model, and also for the coupler. So for the coupler, you can also get the files. So typically creating restart files for Oasis. You can also fill the name list, like CPL will fill the name list. So if you want to have a look at that, you can, but you don't have to modify anything in this script. There is also for the ocean compile script that, as I said, can do the compilation for you if you activate a key. So basically, this is for each model. Then, this toolbox also contains something that is specific to the machine you will run on it, because when you want to launch a job, if you launch a job on Left or on your own Linux computer or another cluster, it won't be the same command. And so you have to specify settings for this machine. So part of the specification, they are actually built when you do source my.mypath, if you remember well. And this accounts for what you have written as machine when you create your config. And these machines, they are actually stored in a directory that is named machine in this script. So if I go script toolbox machine, and you can see that there are a few machines that already exist. There are typical machines that we're used to use, so typically a French supercomputer, but also lateral because we're used to that. There is an example of a typical Linux machine. So if you want to deploy the script on your own supercomputer and it's not there, I suggest you to have a look at what is in this kind of file and check what is more like your own machine. And if you have deployed that somewhere else, you can also give that back to us and we can introduce that so that in the next release of CROCO, you will have it by default.
The last one is the one in South Africa?
Yeah, the last one is the one in South Africa. Actually, it's one that it's not in the official release. I will just put it there because we did the summer school a few months ago, but yes, it's the one from South Africa. Exactly. And so in these different files, so if I go, for example, in that of Leclaru, you can see that we have something that is a header. So I will just open it so that you understand a bit more what it does. The header is typically what will give you the typical sbatch command. So it's what will be put at the beginning of your job. So if you have a machine that is with a given number of CPU per node and stuff like that, you have to create a header like this that is convenient for your machine and so that you can use. There are also scripts about how you launch simulation. So I can also open the launch thing. Here you can see it's a bit more complicated, but it's helping creating the app.conf file that we did yesterday, depending on the number of CPU you will allocate for each model. So it's a script that will help you build how to launch really the simulation. And finally, there are the my-aunt things that actually are where you can put the modules that you will use all the time in this type of machine to compile your different codes and then to launch the code. So basically, here we have all the module load and stuff like that, and some environment variables that are useful with this kind of modules. So yes, if you want to install all this in another computer, try to find the configuration for the machine that is the most close to yours and build a configuration from there. So you just add machines into this directory. Then in the toolbox, you have also a directory named namelists. So if I go into the namelists, you can see that it's typically scripts that will help you construct the namelist for each model. So here again, it's not something that you have to change. It's doing all the SED actually, so the replacement in the different namelists. What you have to change on your side will be the main my namelist, and there it will change the things the way it should. So basically, there is also a directory that is named path, and there is also all the scripts that will change the path to the good executables and stuff like that. So it's typically all these other scripts that they are called by my path or my namelist on my job to build actually the full thing. The last thing that we have is the Oasis scripts, and this you have used it yesterday actually. In this Oasis scripts, the scripts they are also called by the cooking toolbox. But yesterday you copy one of these scripts that was create Oasis restart from time conditions, so you can find it there if you want to by hand, or you see that you have also the create Oasis from pre-existing output files. And so you can go there and use these files, these scripts individually if you want. And you can see that there are also other little files that are actually functions like from work, from WebWatch, etc., that are called by this main create Oasis things. So just for you to understand it there. Then in this coupling toolbox, so now we are in the main directory. You remember I showed you yesterday that you have all these in directory like CROCO in, WebWatch in, WARF in, and in this in directory you have typically settings. So you have base files. So for example, CROCO in.base. It's the usual CROCO in, but in which we have some bracket things that will be filled by the scripts. So if you have opened, for example, the CROCO in.base, you can see that here into brackets, all these will be automatically filled by the toolbox. There are some things that are not filled actually. For example, all these true false flags. So if you want to output certain fields are not other, you have to change it first there. Okay. Then so it's the same for WaveWatch. So I put something about WaveWatch things. So you have all the base file. Each time there is base extension, it means that there are some things that will be filled automatically by the toolbox. But you can see that here we have all the pre-processing name lists, typically reading and stuff like that. And for the shell, we have different settings that are for different kind of coupling, so atmospheric waves, or forcing, or ocean waves atmosphere. And these are called depending on what you will have set up in my name list. So you will choose in my name list an extension that says, for example, OW, and then it will take this shell.in.base.ow and fill the things inside this name list. There are also forward, but I won't take that today because it's not the point. And in the Oasis in, I also showed that yesterday, but you have all the different NumPocal that you can get. So yesterday, we used the NumPocal based OW. So with 6 fields to exchange. So if you remember well, I'm going down. So we have the SSH, the ocean surface currents, and the significant wave height, wave mean period, and wave mean direction. And yesterday we filled all these things by hand, but today it will be filled automatically by the toolbox. But you have also other base file here. For example, if you are coupling with ocean wave and atmosphere, so OWA, there you can see that you have 23 fields. And so it's basic files where all the fields are written. So it's just to help you, actually. But if you want different fields to couple, you can go there and change something. Okay, then you have the directories that are the files directory. So CROCO files, WorkWatch3 files, WARP files, it's where you should store your inputs. So after pre-processing, you put all your input there, and then on my path, you say, okay, the input file are there. And you can see that you also have something that I didn't really talk about yesterday, is the toy. So we have toy in and toy files. What is the toy? It's actually a bunch of Fortran routing, as you can see there. So it's Fortran 90 routines. And it's a little model. It's not really a model, but it's a toy model. So it means that it's a model that actually just reads a file from one of your models and mimic this model by exchanging with Oasis. So we won't use that today, but if you are starting to do a couple simulation and you have issues, it's a good way using the toy to see where you have a problem. Because if you compile the toy and, for example, you couple the toy with CROCO only, you will see if your problem in your CROCO WaveWatch coupling comes from CROCO or from WaveWatch. So basically, this is really a little tool that reads your files and exchange things with Oasis. So Oasis is implemented in that. And you have on the CROCO documentation a little tutorial that explains to you how to use this toy model. It could be also useful for sensitivity experiments. If you, for example, want to do coupling, not coupling sensitivity experiments, you could imagine that first you run your couple simulation, and then you have your outputs from your couple simulation, and you want to see if what you are looking at the process are due to coupled feedbacks or not. So you can rerun one of the model by forcing it with the output of the coupling from the other model using the toy. It's an option. And finally, you have in this coupling toolbox a prepro directory. And in this prepro directory, you can see that there are preprocessing for each type of model that we have. And we have, for example, in CROCO, typical things for preprocessing like CROCO tools param and stuff like that. But we have also a few other tools that we made that are associated, let's say, with coupling, like make grid from work, so you can create a CROCO grid from the work grid, things like that. And in prepro for WaveWatch 3, you can see that we have also some scripts to make the grid for WaveWatch from CROCO grid instead of using GridGen. It's an option. And you can also, you have make WaveWatch 3 grid input files from CROCO. And you also have a few scripts to prepare forcing files for WaveWatch, like from CFSR Win, from CROCO current and level, if you want to do a WaveWatch only simulation force by CROCO outputs, or for North Wing, for example. So these are a few tools to prepare things. I put something about WRF preprocessing also, but I won't talk a bit too much about that. If you're interested in coupling with the atmosphere, you can also go towards the CROCO documentation, and there is also tutorials that explain how to run these little scripts. Okay, so basically, what we will have to modify to run a coupled simulation. As I said, we only have normally to modify the my files. So my and my path, my name list, and my job. So basically, and then we will just submit the job. So basically, the my and my path, if you are in the directory from yesterday, you already modified it, but we can have a check. So in the my and my path, you have the modules, some things, environment settings, and you can check that you have the good path for the coupler, the ocean model, and the wave model. So it's good for me, and you remember that each time that I log into the computer, I have to source my path so that these settings are activated. So I will do that. Then you have the my name list. So the my name list is where you will find all the settings for the experiment you want to run. So first, you see you have the experiment name. So you choose whatever you want. In my case, I will decide to put Benguela CPL, and as I want to do ocean wave, I will name it ocean wave, classical. Then you have to set what type of run. So here again, I will put ocean wave, and this will condition what NAM couple, but based on something it will use. Okay, so this is important. If you don't change that, it won't be the good NAM couple, and when you will launch the run, you will have always this error related on the names of the variables that are not okay. So you put OW, then you have to activate or deactivate some models. So I don't have atmospheric models, so I put 0. XIOS is a server of IO here for the atmosphere. I don't use it. Yes, 1, I use the ocean model. I'm not using XIOS with the ocean model for the moment. And yes, I'm using the wave model. You see that there are also toy options. So if you want to use a toy model, so here I let everything to 0. Then you see that there is a run dear section. So it's saying to you where the run will be performed. So normally you don't have to change that, but you can check and see that you will have a run dear that will be created by the toolbox actually. And then your experiment will run in a directory under run dear named with the name of your experiment, execute. And the output will be put then, if your run is successful, in the same kind of directory, but is named your experiment name output. And the restart will be stored in experiment name restart. There is also a job directory that will be created where you will find the log of the job. Then you have an executable path section. So here you have to check again that everything is fine. For the ocean, you can see that the ocean model will be coupled in CROCO-in. So indeed, the executable will be fine in CROCO-in. So that's okay. Then for the atmosphere, we won't use it, so let's skip that. For the wave directory, you can see that it's under $wave. that is actually set up by my ordinal path, and then executable underscore runtime. So here OW. So indeed, that's where I put the executable from Wavewatch to run in couple run. Toy we won't use, and XiOS, so nothing to change there. Then you have section for the coupler. So in this section, you can check also that it will use the non-couple name non-couple.base.runtime, which is OW. So that's what we want. Then you have to set up here the coupling frequency. And to do the same than yesterday, I will put here 6 hours, so 21,600 seconds. Then it says, am I starting from existing condition? No, I want the coupling toolbox to start from cold condition, so I put false there. So I don't have to prescribe any Oasis restart file, but if I'm starting from a run that I've previously done, I could have prescribed and say to the toolbox, okay, my restart files are there. And then here, eventually, I could also say to the coupling toolbox that I already prepared my weight file, so for remapping, for regridding within Oasis. Either the Oasis can just compute this remap file at the beginning of the simulation, depending on what we have prescribed in the non-couple, or you can also prepare them in advance. If you have a very complicated coastal area, for example, sometimes it's useful to really prepare very specifically the weight of your interpolation because you have complicated domain, and you can also do that. So here we will leave all this like that. Then you have the ocean model section. So here its name is for the ocean model. So first it asks you, do you want to have online compilation? So this means that the toolbox will compile CROCO for you. So I will put, okay, yes, well, I want toolbox to compile CROCO for me. Then you have the time steps. So here indeed I will run the Benguela with a 1 hour time step and with 60 barotropic time step in 1 baroclinic time step. Then you have to prescribe some parameters, like for example, the H-min parameter, which is specified in CROCO tools, so it's 75 in my case. You can also run a couple model with aggregate zoom, so there are some sections for the zooms, but we won't do that today. And there are some also settings for options to compute only on the ocean and not on the land. So I won't detail that today, but there are some options that can be done. If you are not activating this key, CPP key, actually, you don't mind and you can let all this to false. Then you have the forcing files. So you have to decide which forcing file you are using. So for that, you remember it was in CROCO files, we put some soda files. So indeed here we will use ini soda. We will use boundary soda also. We will indeed use a surface forcing because we have a bulk file. Eventually, we can activate online interpolation. It's a way for CROCO to force in bulk mode without preparing the bulk file in advance. So you can give ERA file kind of native grid, and then CROCO will interpolate at the moment it's performing the run online. But for that, it's different. I will show this afternoon that we can activate that for the case you can do tomorrow morning, for example. But for now, you remember that yesterday I had in my CROCO file the bulk ERA file, so I will stick to 0 today. And here you see, as a forcing, I prescribe indeed bulk ERA file. Okay, I don't have tides in my case, I don't have rivers. So I let everything to false. And here, I can prescribe also the time steps for the output. So for history and for average. So I will keep that. So it's basically every 24 hours. Then you have the atmospheric section that I will skip because we won't do atmosphere. And then you have the wave section. For the wave model, where you can find again here the different time steps for the wave model. So indeed, it's already set up for the regular case, so you don't have to change anything, but it's a 1 hour global time step, etc., etc. And you can see that as a comment, I put some insight on how to compute these time steps for your own grid. Then you have to press. Yeah, you have a question?
So by default is the same resolution?
Yes, at the moment by default it's the same resolution than the CROCO. Yeah, I made the grid for the CROCO. Okay. Then as a grid size here, you have to prescribe the wave grid size, so 41, 42, the usual Benguela. And here you have to prescribe the forcing for wave watch. So here we want forcing, so we want a wind forcing. So we will say, okay, I want era 5 wind. So this is the prefix of the file that I have. So if you check into wave watch 3 files, you will find that I have a wind that is named era 5 wind with a date 10. So it is written as a comment, prefix, underscore, year, month, the dates. So if your file is not named this way, you should rename it this way. Then here it's a keyword to activate or not different forcing. So here I will activate wind. It's for using the PRNC, so the preparation of the forcing. So if you are running a wave watch only simulation with forcing also of current and levels, for example, you should add some keywords there to have current and levels prepared. But today, wind only. Then if you have boundary conditions, so spectral boundary condition, you can also activate something there. We don't have for today, so we will keep it that way. And finally, you have some things for outputs. So every how many seconds you want some output. So here I will put every 6 hours, for example, as yesterday. And then you have this last wave file that is important. You remember it's a file that is generally issued from a previous run, and the file to create a restart condition for Oasis, as we did yesterday. You remember I gave you a file. It was, so I will change it. It was in wavewatch 3 files, and it was named wavewatch 3 underscore 2005 for 1.s. So basically, you have to change this line. So generally, you have to perform first a force simulation to have an output file, and from this output file, you can use it to create a restart condition for Oasis. So once you have that, there is also a section for the toy, but we won't use the toy, so I just give you some insight. But for the toy, you can choose what toy type you're using, so either wave or atmosphere, ocean, or you can have a toy for both the atmosphere and the wave, for example. And you can also say to the toy, use this kind of files to run. But we won't use that today, and there is a section for XIOS, which is a NIO server that can be also used eventually. Okay, so now the my name is set up. There is one tiny thing in addition to my name list and then my job is, you remember yesterday we had for wavewatch 3 to prepare the prnc.in for era 5 forcing. And we have to do that also today, because by default it's prepared for CFSR, I guess. And so in the wavewatch 3 in directory, you have this prnc.in.wind, so we want wind. And here, if you remember, I changed yesterday the names of the longitude, latitude, and of the variables. So I will do that again here, because it's not done automatically. As you can see, it's not into brackets. So when it's not into brackets, it's not done automatically. And then I have to change that, otherwise it won't understand my wind forcing. So I change longitude, latitude, use V10, and I save this file.
So the wind,
I don't.
Latitude, longitude, and
And the variable names, yes.
What?
U10, V10, and it's not capital letters, it's small letters. Then, if I come back to my main Benguela CPL directory, I will modify the last script for the my job. So as I said a bit earlier, my job is containing dates and settings for the job in general. So first, you have the job wall time. So the wall time is the time that you will ask the computer to allocate you the nodes. Okay, so here I will let that, so it's half an hour because my run is quite fast. But if you're running a simulation and you need 24 hours to book the node for 24 hours, you have to change this time job. Okay, it's given in seconds, but it's a wall time typically, and it will be changed in the S-bash instruction for electoral routine.
Just a comment on that. This helps you to in electoral to start, so your job starts faster. If you don't,
Yes.
if you don't say job time, and you ask 2 nodes, the trial doesn't know you will use 2 nodes for 3 days or for 2 hours.
Yes.
But if you say, oh, I need 2 nodes only for 2 hours, okay, then, okay, you go first, finish, and then we can. It's optional, but it's good because can help your run to start faster.
Yes. And so when you are, generally what you should do if you're starting a simulation is first decide to just run for a few days with a small wall time. So you go directly, you won't wait in the queue, you will be first, and then you can also know how long your simulation takes to run, depending on the number of processors that you have. And from these few first days of simulation, you can compute how time of machine you will need to compute true simulation in the end. So you should have this habit of first doing small things. And when you're sure that everything is working, then you can go for your production simulation, let's say. So here it is, some machine request that you ask for a given project ID. So we have this variable that exists, but for us today it won't. Then you have the date setting. So I will start 1st of January 2005. I won't run for a full month, but I will run for 30 days, for example, here. So I change, I want 30 days. So it's the duration of my job, okay? And how many jobs I want to launch. So here I just want to launch 1. But for example, if I want to run 3 months, starting January 1st, I could have put, so January 1st, I could have put 1 month. I want 3 months, but I will do 1 job each month. So I will put 1, and here I can put 3. So basically, what the script will do is first running the first month of January, and then it will create restarts and everything, and will launch the job for February, and then store the output, keep restart, and then launch the job for March, okay? So I won't do that now, but it's a possibility. And so this my job file will be changed automatically by the script to run the next month. So you will see that at the end of the simulation, it will be different than what we are setting up now. So I put 0 months, 30 days, 1 job. And I'm not starting from a restart, so I put false, but if I have a restart, I could put true. Chain job is a way of chaining job depending on the machine. I won't detail that, but if you want more detail, you can ask later. There is some test mode, debug mode you can try. And here there is a multi-step. If you keep XXX, it will do all the steps. That is creating files, running the model, putting files, so we want everything indeed. And here you can see that then you have MPI settings. So typically, first you have the MPI command that we will use. And here you can see that it's this environment variable named $MPI launch, and it's set up already in my path. So we don't need to change that. And there is also a serial launch command for the wave model depending, because you remember for the wave model first, the script will do the WW3 grid, then the PRNC, then the start, and then it will launch indeed the couple simulation. So this is for serial launch, depending on how you have compiled your executable for WaveWatch first. And here you have the number of CPU you will allocate for each model. So it will be changed in param.h before compiling the ocean model. So I can change from yesterday if I want. So whatever, I will go with 2 and 2. And for the wave model, for example, let's say that I will run on 4 processors. And I don't care about these other numbers because it's for atmosphere, toy, XAOS. I don't use them so that I don't have to change anything there. It won't be used. So here I've decided to run on CROCO on 4 processors, and WaveWatch on 4 processors. Okay? So these are additional settings for WARF. And that's all. You arrive at end user change, meaning you don't have to change things under that. So I can save. And now I'm ready to launch the run. So I will launch. Very easy. Submit job. Enter. And I wait. So this will aggregate all the settings that I've put in my class, my name list, my job, and it's starting to launch a run. So give me a few information. Okay, I'm in Letraru, I'm working there in config Bengola CPL. The host name is Letraru, the experiment is named OW, Bengola CPL OW. The job name is named like this. It's typically the experiment name and the dates. And then it gives me a few paths where execution is done, where output will be stored, and where restart will be stored. And it says, okay, it was submitted batch. So now if I check on SQ, which is the command to check what's happening, I can see that my job is pending.
You don't need the input file for the CROCO.
Yes, I need the input files for CROCO. There are CROCO files here. And typically, in my name list, I said, okay, I want to use inisoda. So it will use inisoda and the date, because it's saying, it's okay, I'm working on 2005 month 1, so it will use this initial file. For the boundary condition, it's also using boundary soda. And for the atmospheric condition, it will use bulk error files. So automatically, it goes into CROCO files. It's checking this like prefix name, CROCO bulk error file, and the date, and it will copy all this in my execution directory so that it can be used by CROCO.
And this you got them yesterday.
Yeah, this I got them yesterday, exactly.
Link them from.
I linked them from, if you have linked on the first day's data directory to your home, into this data directory you have CROCO files, and inside this CROCO files you have all the input files that you will need.
Okay.
So I'm pending. And basically, I will just show you now. Already, while launching Submit Job, I have a directory that has been created that is named jobs Bengola CPL OW. And in this directory, you can see that I have a job.sh file that has been done. So actually, it's the script has already prepared my job. And I can have a look rapidly at it. And you can see that it says aggregate a lot of information. So first it says aggregate like the sbatch command for Lexaran. It has source environment, and here you can see that it has aggregate all what I set up in my name list first. I'll go a bit further down. So it's all my name list stuff. That is a bit long. And then it aggregates all the my job stuff. So here you can see job settings, job submission settings, and with the date that I've chosen. And then it has submitted this job. So it does submit as batch jobs, and that's why now I'm pending, I'm in the queue. I haven't put the special queue because it's the usual command, but should not be too long. But basically, I will just open my other account on which I already run it to show you that once it will be launched, I will have also another directory that's named rundir. And in this rundir directory, you will have three files, three other directories. So one is the execute, the second one is the output, and the third one is the restart, as I said before. And where the run was executed is execute, obviously. So regular execute. And then there is a date. So because if you want to do the next month, you will have another directory with the next month. And here you will have where the execution happened. And you can see that the toolbox has brought there everything. So it has brought there the executable. So typically you will have here exactly the same thing, the same file that is brought to the run test OW yesterday by hand. So you have the executable, they were renamed automatically. You have the input files for CROCO that were linked there. You have the inputs for WaveWatch 3 that have been linked there too. Then you can see that we have the .ww3 files that have been done. So grid has been run for WaveWatch. PRNC then has been run for WaveWatch 3 too. And then you have star that has been run for WaveWatch also. So you have all this and you have the output that will appear. And then the num couple has been filled automatically. And finally, you can find the Oasis output. So typically the nout that we have had a look yesterday, the netcdf files created by Oasis, the remap file also created by Oasis, and then you have the debug files that you can find. So here you can see I don't have any output for my job. Why? Because the netcdf output for CROCO and WaveWatch I have been put in the output directory. So it's in Benguela outputs. And here you can see also under date that here, okay, I have my CROCO average, CROCO history, and the name has been changed to have the dates also in the name. And you also have the binary output from WaveWatch and also the netcdf output from WaveWatch because the UNF has been run also automatically. And you also have the restart that have been created in the restart directory. So here you have the restart that appear. And so we have all the files that could be used if I want to restart a run for the month of February. So typically I have the files for WaveWatch, so the moddev, so I won't need to rerun the grid. I have the different files for Oasis to be restarted. You can see that I also kept all the remap files because this part of remapping, if your grid is small, it will be fast. But if your grid is big, the computation of the weight for the interpolation between the grids by Oasis can be quite long. So typically, if you do multiple months simulation, you don't want to recompute the exact same weight at the beginning of each month, and so you keep these files, and then they will be used at the next run and not recomputed. So let's check if I run on the other side. Yes, it's running. So and you can see that it's running and that actually at the moment it's, I think, or it has compiled CROCO. So if I go into CROCO in, you can see that it has changed a few things, and that's the CROCO.ow has appeared, and this is my executable that just has been compiled automatically by the toolbox. So it has changed something in cppdefs, in param.h, and if I look here, by the way, param.h, you remember I decided to use 4 CPUs for CROCO, 2 for the C and 2 for the eta direction. And if I have a look at param.h OW, and I go to the MPI settings, you can see where are they here that indeed I have 2 CPUs for each direction. And this has been automatically changed by the toolbox. So basically, this is the idea of this toolbox. So if you have filled the thing the same way as I do this morning, probably it will work. If it's not, probably you have an issue either in the past. Basically, the issues can be only generally in my past, my name list, or my job, because all the rest is everything is automatic. So I strongly advise you to, even if you want to compute your own simulation on a different era, start trying with the Bengala CPL with that, and once that is working, okay, you can change the area and build your simulation for a different area. I guess it's for tomorrow.